So in this video, we're going to take a look at identifying whether the properties are for a translation or a reflection, and then we're going to apply these. So this is just kind of a quick way to review both. So the properties after a translation or of a translation, or a translation is just sliding things right, left, up, down. So there's a difference in position, but they're going to be in the same orientation. The side lengths will be the same. The perimeter, the area, the angle measures, they're going to be congruent. Really nothing changes except for the position, right? They just move. So it looks like if I move the blue one to the red one, I scoot it over to the right and then down just a little bit. But everything else about the figure is exactly the same. So now the properties for after reflection, so they're still going to have mostly the same properties. So the side lengths, perimeter, area, angle measures, and congruence are the same. So the figure itself has not changed. It's still a congruent figure. But what is going to change, the position and the orientation have changed. So now it has moved over. It has not only just moved over, but it flipped over. Because literally think of a reflection like in the mirror. It's backwards, right? It completely flipped over. So we do have these three rules that we went over in a previous video about rotations. So 180-degree rotation means that we flip, if we have a coordinate x, y, then we just change the sign for both. If we have a 90-degree clockwise, remember that's clockwise as far as like literally a clock, so going the correct way in a clock. Now x and y switch spots, and whatever the x was, it's going to switch signs. Okay. Now if it's 90 degrees counterclockwise, then we still switch spots with x and y, but now y becomes negative or switches signs. Now remember, we can also go backwards on a clock, so that's what counterclockwise means. I'm going backwards. So 90 degrees clockwise or 270 degrees counterclockwise mean the same thing. And then 90 degrees counterclockwise or 270 degrees clockwise also mean the same thing. It's about where you land when you're going that direction. All right, so let's go ahead and take a look at these figures. And with this one in class, I know I said use a sheet protector or a projector sheet to draw figure A, and then move the sheet as indicated to determine if the transformation will produce the figure. So instead of just drawing over and over again on the same sheet, that would be a really good way to do it in class. If you don't have that at home, then you may want to try copies or just very lightly draw on it so that you can kind of test these all out, because we may be doing more than one thing with them, so it's a little harder to just see whether or not it fits. And more than one of these can work. So with this one, the first thing I want us to figure out is, are figures A and B even congruent? If they're not congruent, then there's no point to even do this, because it cannot be one of our transformations if it's not congruent. These are called rigid transformations, which means the shape isn't going to change. Now, when we do dilation, we have done that in the past. That changes the shape a little because that changes the size. But for translation, rotation, and reflection, the size and shape do not change. It's just moving around the coordinate grid. So these do, in fact, look congruent, right? So on these ones, I would say yes, they are congruent. So now we can work on our rigid transformations. So which transformation will map figure A onto figure B exactly? So translate figure A to the left 7 units. All right, well, if I take figure A and I translate it to the left 7 units, I'm going to land over here. So that didn't work, right? So that's what I mean by take your projector sheet, trace this, and then just scoot it over so that you can see. Instead of having to redraw it over and over again, you can just kind of test it with that clear sheet. All right, so now we're going to do this again. So now translate figure A 7 units down. So now I'm going to go down 7 units, and I do, in fact, land right on top of what I was supposed to land on. So that worked. Yay! So we do like that one. Now we're going to test the next one. We're going to reflect figure A over the x-axis. So if I reflect, remember that means that it's going to flip over. It's going to be a mirror image. So that doesn't work. That's upside down, right, from what it's supposed to be. I can reflect it over the y-axis. So I'm going to take figure A, and I'm going to reflect it over. I think that was supposed to be up there. I'm not sure why it's got scooted down here. So reflecting over, but that doesn't work either because that's over here and it needs to be down here. So now rotate figure A 180 degrees about the origin. So now I'm going to take this and I'm going to rotate it. You can see this crazy rotation. So that's 90. So if I keep going, and I'm stopping just so you can see, here's the 180. So that wouldn't work. That's not in the right spot. And now I'm going to rotate figure 8 90 degrees about the origin. So I'm going to go this way. Well, again, it's close. It's kind of in the right spot, but it's definitely the wrong orientation. So that didn't work. So we only have the one thing that worked here. Okay. So again, this is why I'm saying, draw it on a projector sheet or a sheet protector so that you can kind of just spin it around or move this as you need to instead of having to, deal with all of those drawings. All right, so now let's look at figure D and figure C. So are they congruent? Yes, they do in fact look congruent to me because I have 2 along the bottom here and 2 along the side, 1 and 1. This slope is the same as this slope, meaning that I'm going over, down 2 over 2. So with this one, I can kind of see that if I picture it the same way, I'm going down 2 over 2, and then this is a length of 3. So I can, in fact, go around and make sure that matches. So do we have to test each and every situation? Not necessarily, because if we kind of think about this, we can eliminate some of them, because just translating, well, that's not going to change the orientation, right? Translation, I'm just going to scooch it up. So anything with just translate isn't even going to need to be tested, right? Only a rotation can work for making it do this. So, because even a reflection, it would be upside down from this one, but it's not going to be sideways, right? So really, I only have to test the rotations. I don't have to test each and everything if I understand they're not going to give me what I need there. So let's just test the rotations. So rotate figure C clockwise, 90 degrees about the origin. So I'm going to go 90 degrees. Sorry, crossing all those off. So let's go 90 degrees. And this one does, in fact, land exactly where I want it to land if I rotate that 90 degrees. And if you're doing this with the sheet protector, what I would do is use your pencil and kind of put pressure on the origin and just spin it 90 degrees. That's kind of the best way so that it doesn't move too much. So you might kind of poke a tiny little hole in the sheet protector just to kind of help you spin it. So now, if I try that other piece, the rotating the figure C counterclockwise 180 degrees, that's not going to get us where we want to go, right? Because if I go counterclockwise, that's going to land over here because 180 is kind of across from the original figure. So only this clockwise 90 degrees about the origin would work. So that's determining if figures are congruent and related by a transformation. I hope that helped, and I'll see you in the next video.